This is exercise 2 related to electrolysis and the chemical cell, because there are two parts in this. Electrolysis, one is about electrolysis and another one is a chemical cell. And exercise 1 is about MCQs and exercise 2 is the structure questions. But we'll not do, because all the chemical cell questions, as we did not complete that topic, we are only doing electrolysis part. So we have a question here. We have aqueous copper 2 sulfate solution is electrolyzed using a carbon electrode. So we are using a carbon electrode and we have the ions. They already give us the ions which are present in the electrolyte. We have copper ion, we have sulfate ion, we have hydrogen ion and hydroxide ion. So two positive ions are there, two negative ions. Write an ionic equation for a reaction at a negative electrode or cathode. So cathode will attract the positive ions. The positive ions will move towards cathode. We have two positive ions. We have copper, we have hydrogen. Which positive ion will move towards cathode? Which positive ion will move towards cathode? We are doing electrolysis. The two electrodes are there. You can use a chat, you can use mic or a screen annotation. This is, say, an anode is there and the other one is a cathode. So which positive ion will move? As I mentioned, hydrogen only move, like most of the cases, hydrogen move except this silver or a copper. So which positive ion will move here? So copper will move. So as the copper will move there, we have a copper that is attracted towards the cathode. When the copper is attracted towards the cathode, we have to write equation for that. So copper is Cu with a charge +2. So if Cu is there with a charge of +2, what will happen? It will take 2 electrons and it will turn into copper atom. So copper ions gain 2 electron and turn into copper atom. That's the equation for a negative electrode or a cathode. Is it clear, this part, the first part? Anyone having a doubt or a question in this? Okay. The next part, the second part, the colorless gas is given off at a positive electrode or anode, and the solution changes from blue to colorless. We have to explain these observations. First, we have to identify which colorless gas will be there. To identify which colorless gas is given at anode, you have to check which ion will move. So there are two ions which are present, sulfate ion and hydroxide ion. Which ion will move? Which ion will move? Sulfate, nitrates, and carbonate never move. Whenever there's a sulfate ion, nitrate ion, or carbonate ion, because of their mass, they're not able to move in the electrolyte. So which ion will move there? The hydroxide ions will move. So when these even if it was a concentrated solution, sulfate is more, but again, it cannot discharge. So the hydroxide ions are attracted towards the anode, so they will move towards anode. And when hydroxide ions will move there, we have a fixed equation for a hydroxide ion, that when 4 hydroxide ions are moving there, they give off oxygen They produce two water molecules and they will lose four electrons. So explain this observation at the colorless gas is given off. So what is this colorless gas given off? The colorless gas is oxygen. And why it is formed? Due to discharge of hydroxide ion. So the colorless gas is given off due to a discharge of a hydroxide ion. That's a first. And the second thing, we have to explain the observation, like why the solution get paler or lighter or blue color disappear or it become colorless, because copper ions are blue in color. The color of this copper is blue. So as these copper ions are blue in color, as the copper ions are discharged at cathode, or amount of the copper ion will decrease in the electrolyte. That's why the solution will become colorless, or you can also say paler. You can say it will turn into colorless. You can also say it will turn into paler. So copper ions are blue. So when they move out towards the cathode, or you can also use the term when they discharge, the solution turned paler or lighter. Yeah, this is also right. You can also mention about the reduction as well, like because the copper ions are reduced and removed from the solution, so it loses blue color. So both ways are correct. You can mention any. Is it clear, this one? Anyone having a doubt or a question till this point? This is another part, like using the copper electrode, what will happen. But right now we are doing a simple electrolysis. Okay, in this question, which is related to oil rig, as you can see, titanium is a very resist to corrosion, and one of its used as an electrode in cathodic protection for a large steel structures from rusting. So you can see a battery is there. If a question was there, draw an arrow to show the movement of electron. From the negative terminal, electron will move out. So majority of the electrons will be here on this structure. And towards the positive terminal, the electrons are attracted. So most of the positive ions are here. This will be the movement of electrons. Define the term oxidation in terms of electron transfer. How we define oxidation? What's the definition of? So that's right. Oxidation is what? Oxidation is a loss of electron. When something lose electron, we call oxidation. So oxidation in terms of electron, it is a loss of electron. So anything loses electron, we call that as oxidation. The next part, the oil rig is cathode. Name the gas formed at cathode. So towards the cathode, the positive ions will move. So we have two positive ions. We have hydrogen ion and we have sodium ion. So which hydrogen ion will move towards, like in the sea water, we have hydrogen ion, hydroxide ion, sodium ion, and a chloride ion. So which positive ion will move towards cathode? It is Na plus or H plus. So which ion will move? Is it Na plus or H plus? So in this case, the H will move, the hydrogen ions will move there. So when hydrogen ions will move there, as a result, what will happen? The equation, when hydrogen ions will move there, they will take two electrons and it will form a hydrogen gas. So there will be bubbles. So which gas is formed? There will be a hydrogen gas. Then name the two gases formed at titanium anode. Now, what will happen? Because it's an aqueous solution and you cannot say a seawater can be concentrated aqueous or a dilute aqueous. Both ions are present. So some cases, what will happen? The hydroxide ions will move there, and some cases the chloride ions will move there. So when hydroxide ions will move there, so whenever the hydroxide ions will move there, they will give oxygen gas. When chloride ions will move there, it will give chlorine gas. So in this case, we'll have both gases, hydrogen and chlorine. Why hydrogen is there? Because, sorry, not hydrogen, oxygen and chlorine. Why oxygen is there? Because of when hydroxide ions discharge, it will give off oxygen. When chloride ion discharge, it will give off chlorine gas. Is it clear? The third part, the two gases which are formed. How we know there are two gases? Because in the question they mentioned there are two gases formed. In the question it is mentioned the two gases formed. So how two gases can be formed? If a hydroxide ion discharge, it will give off oxygen. If a chloride ion discharge, it will give off chlorine. So as a result, there will be two gases. Anyone having a doubt or a question in this part? Now, this one is a table which you have to complete. Some cases, the products are given and you have to name the electrolyte. In some cases, the electrolyte is given and you have to complete a product and the change in the electrolyte. The first row is done for you. In the first row, we have molten lead to bromide. So this Roman number shows a valency of a lead. So lead will be +2 and bromide means bromine, which is a group 7. Lead ions are positive ions. So positive ions are attracted towards cathode. The bromide ions are negative ions. So they are attracted towards anode, the positive electrode. And whenever there's a molten substance, the electrolyte is always used up. Now here we have to just complete the empty spaces, identifying. So this contain potassium ion because the potassium is formed, and this contain iodide ion. And when the electrolyte is used up, it must be molten because molten electrolyte used up. So what is this electrolyte here? What is the electrolyte here? You can use a chat, you can use mic or its screen annotation for this. You have to mention the state as well.
Molten potassium iodide.
Good. If you just write potassium iodide, that's not a complete answer because you have to mention whether it is aqueous, whether it is like aqueous concentrated, aqueous dilute, or it's a molten. So because the electrolyte is used up, so we'll say it is molten. And because of potassium ion and iodide ions are discharged, so we'll say it is molten potassium iodide. The next one is dilute aqueous sodium chloride. First, you identify the ions in dilute aqueous sodium chloride. So it contains sodium ion, it contains chloride ion, and because it's an aqueous, so it means it contains H ion and OH ion. Change at negative electrode, like which, because at a negative electrode or cathode, the positive ions will move. Which positive ion will move? Is it sodium or H plus? Which positive ion will move?
Hydrogen.
because when we have two positive ions, or hydrogen will move except there is a copper or silver. So hydrogen will discharge until unless there is a copper or silver. So what will happen? In this case, the hydrogen will discharge, hydrogen will move. So what is a product form? We don't have to write the equation. We just have to mention a product. So we'll say hydrogen form. For a negative, the negative ion, we check the amount, like the ion which is more in the solution will move except there is a sulfate, nitrate or carbonate. So in this case, it's a dilute solution. Dilute solution means it contains more OH and less Cl. So when hydroxide ion is there, which product is formed? We don't say hydroxide is the product. We say oxygen is the product. So because it's an aqueous dilute, so hydroxide ions are more. When hydroxide ions are more, what will the observation here? We'll mention the product will be oxygen. Is it clear, this one? Subhan, Sarah. So whenever hydroxide ions are there, the product will be oxygen. Don't write hydroxide as a product, because hydroxide ions are the one discharged, and as a result of a hydroxide ion, we get oxygen as a product. Now, hydrogen is removed and hydroxide is removed. What happened to the electrolyte? So electrolyte will be sodium chloride, but the H and OH ion are being removed. So we can say it will become concentrated aqueous sodium chloride or aqueous concentrated sodium chloride. Why aqueous concentrated sodium chloride? Because more salt will be there and less water is there, like H plus ion and OH minus ions are less. That's why it will become aqueous concentrated sodium chloride. The next one, we have aqueous copper 2 sulfate. Why it's not written dilute or concentrated? Because it does not make difference. As there is a sulfate ions never move. So what are the ions present? We have a copper ion. We have copper 2 ion, sulfate ion is there, H plus ion and OH minus ion. So which positive ion will move towards the negative electrode or cathode? Is it hydrogen or copper? Which ion will move? Hydrogen or copper?
Copper.
So copper will move. So when copper will move, the product here we will mention, there will be a product, copper will be there. For aqueous solutions, we check the amount, but sulfate, nitrate and carbonate never discharge. So we are left with hydroxide only. If there's a hydroxide discharge, what will be the product? So due to discharge of a hydroxide, there will be an oxygen gas. And what happened to the electrolyte? Electrolyte means what we are left with. We are left with H plus and SO4 minus. So H plus and SO4 minus, what is the compound formed by these two ions? This two will be with hydrogen and one with sulfate. So it will become H2SO4. And what we call H2SO4, we call that as a sulfuric acid. So this time the electrolyte will turn into acidic because it contains hydrogen sulfate, which is a sulfuric acid. Then the last example, we have hydrogen is formed here. So we have a bromide, bromine is formed, so bromide ion, and the solution turned into potassium hydroxide. So what will be the original solution? Because potassium and bromide, like what actually happened, we have in the electrolyte, we have potassium ion, we have hydrogen ion, we have bromide ion, and we have hydroxide ion. So for positive ion, because hydrogen will move, and for negative ion, the ion which is more in the solution will move, as there is a bromide ion is moving because bromine is discharged, so bromine is more and hydroxide is less. So it is aqueous. Because the salt is moving, the negative ion from the salt is moving, so it is aqueous concentrated potassium bromide. So it must be aqueous concentrated potassium bromide. Negative ion of the salt will move, like potassium bromide is there, K plus and Br minus. So bromide ion is discharging, it means it contain more salt and less water. That's why we say it is concentrated. Is it clear how we completed this table? So this is like the table about the electrolysis, some examples about electrolysis. Example, if you have a molten sodium chloride, so molten sodium chloride, it contains sodium ion and chloride ion. So sodium ion will move towards cathode and chloride ion will move towards anode and the electrolyte will be used up. But if we have aqueous concentrated sodium chloride, so it contains sodium ion, hydrogen ion, and it contains chloride ion and hydroxide ion. So in this case, the hydrogen will move. That's why hydrogen will be there as a product at cathode, negative electrode. And because it's a concentrated, so chlorine is more, so that will be the product at anode. And the electrolyte, nothing is left, so sodium hydroxide will be there. Aqueous dilute, if we have the same solution, but we have a dilute solution. So hydrogen ions are there, H plus ions. And we have it's a dilute solution, so hydroxide ion is more, so this will discharge. So when 4 hydroxide ions are there, they will give up oxygen, 2 water molecules, and 4 electrons. And what happened to the electrolyte? The electrolyte is turned into sodium chloride, you can mention concentrated because the water is being removed. And if we have lead 2 bromide, so lead 2 bromide contain lead ion, potassium bromide contain potassium ion and the bromide ion. So potassium will move towards cathode and a bromide ion move towards anode, and the electrolyte will be used up. If aqueous concentrated potassium bromide, so then hydrogen ion and the bromide ion, and it will turn into potassium hydroxide. If we have aqueous concentrated or a dilute sulfuric acid, it won't make any, if we have aqueous or a concentrated dilute copper sulfate solution, it won't make difference to the product because the copper ions are less reactive, so they will move towards the negative electrode. And hydroxide ion, even they are more or less, because the other ion is sulfate ions does not discharge. And this one again, a lead 2 bromide is there, so lead ion will move and the bromide ion will move. So this was about the electrolysis, some questions related to topic electrolysis. I'll share a file on the group now, and you all have to solve and submit that today related to electrolysis of a compound. Any question or a doubt related to the session today?
No, sir.